Everyone. I welcome you to the fifth session of Electromagnetic Theory and Interference course. Today's session we will be looking into spherical coordinate system and the transformation between Cartesian and spherical coordinates. So let us see first what is spherical coordinates. If we want to specify a point in spherical coordinate system, so the point P is specified at the radial distance r, that is the radius of the sphere, and azimuth angle it is making with the x-axis, that is phi, and the polar angle that it makes with the z-axis is nothing but theta. So the limits of the coordinates are the radius varies from 0 to infinity, whereas the theta angle will have only 0 to 180 degree rotation, whereas phi angle is same 0 to 2 pi as that of cylindrical coordinates. How will I write a vector in spherical coordinates? The A vector is written as AR, component of A along the radial direction into AR cap plus component of A along the theta direction A theta into A theta cap plus A phi into A phi cap. If I want to find the magnitude, I just have take the square root of sum of the squares of the components along each of the axes. So from let us understand how the dot product of two vectors and spherical coordinates is going to happen. So we already know that dot product of same vectors, same unit vectors will give me the result 1. So along each axis it is mentioned, whereas dot product of different unit vectors, suppose AR dot A theta or A theta dot A phi or A phi dot AR, everything is going to be 0. Whereas if I come to cross product, vector cross product of the two consecutive vectors in this direction will give me the so suppose AR cross A theta cap will give me A phi cap. If I want to take the reverse like A theta first and if I cross multiply with AR, I will get negative A phi. Similarly, in other two sets it has been mentioned, that is A theta cross A phi, it is AR cap, A phi cross AR cap is equal to A theta cap. So let us now understand the differential elements. So differential length vector. So already we have seen a point P with having the radius r. Okay, now it is extended to dr, whereas my theta is extended to d theta, but the arc length will be r into d theta, the differential element. Whereas my phi is now extended to d phi, but if I want to write the arc length, it is going to be, so it is varying with respect to the rho. Okay, rho of my so rho into d phi, that is r sine theta d phi. It is varying with respect to r sine of the polar angle and d phi. So the same is represented here. Dl vector is dr into ar cap plus r d theta into a theta cap plus r sine theta d phi into a phi cap. Now let us see how to write the differential surface area along the radial axis. So for radial axis, I have these two differential components, that is r d theta, r sine theta d phi components. So the product will give me r square sine theta d phi into the unit vector perpendicular to the surface, that is AR cap. Similarly, for surface area across the theta direction is it's a product of dr into r sine theta d phi and multiplied with unit vector a theta cap. Similarly, for ds phi vector, it is dr r d theta into a phi cap. Now let us see how to write the differential volume. It is going to be the product of the differential length element. Okay, so that is dr into r d theta into r sine theta d phi. So it turns out to be r square sine theta dr d theta and d phi. This is my differential volume. Now let us see how the transformation is done between Cartesian and spherical coordinates. For that, the point P is considered in the XYZ plane by considering both the cylindrical and Cartesian coordinates. So I am mentioning this point P where it is at a radial distance r, it's a radius of sphere, and it is at a height z, and from the x-axis this point makes an angle phi, and from the z-axis this particular point makes an angle theta. So we already studied in a cylindrical coordinate system by using the lower portion of the triangle that is mentioned here. We found the relation between Cartesian and cylindrical coordinates, that is x is equal to rho cos phi, y equal to rho sin phi. This we already found, right? So from this expression we need to substitute the value of rho here to get the spherical coordinates. For that I am taking the upper portion of the triangle where theta angle is mentioned. So to find the value of rho, I am going to take, so first cos theta, that is adjacent by hypotenuse, that is z by r, and from here I can find the z value, that is z is equal to r cos theta. Whereas if I take sin phi, which is opposite by hypotenuse rho by r, I will get rho equal to r sin theta. That rho value is substituted in this above expression, and we got x is equal to r sin theta cos phi, y equal to r sin theta sin phi, and this we already got, z is equal to r cos theta. These are the points when my spherical coordinates are given, I can easily find x, y, z points. If suppose I want to do the reverse, I have the x, y, z in my hand, I want to find r theta phi, what should I do? So we have to see the relation. So take this right angle triangle, apply the Pythagoras theorem to find r value. It is going to be the square root of rho square plus z square. Where rho we already know it is going to be root of x square plus y square. So substituting here the value of rho, we get r is equal to root of x square plus y square plus z square. And to find the value of theta, what should I do? Here it is theta, I'm sorry, here it is theta. So to find the value of theta, what should I do? I have to take tan theta, that is, I have to divide sin theta by cos theta, I will get rho by z. Okay, where rho we already found from this relation is root of x square plus y square plus divided by z. Okay, and phi we already found from the cylindrical, that is tan inverse of y by x. From this above triangle only phi is found. So that's all about the conversion between the coordinate points. Now let us see how the conversion is done between the unit vector quantities. So to find AR vector, what should I do? I should take the general relation of the differential length element in spherical coordinate system, where dl vector is written as dr AR cap plus the differential element along the theta direction is r d theta a theta cap, plus here along the phi it is r sin theta d phi cap, sin theta d phi a phi cap. So to find AR vector, what are the other coordinates? Theta and phi, both are constant, and the differentiation of them will be 0. Similarly, to find A theta, the other two components are constant and differentiation of them is 0. Similarly for A phi component. So how will I find AR vector? It is dl vector divided by dr. Similarly, the unit vector AR cap, I have to take the differential element in the Cartesian coordinate system, and I have to differentiate with respect to dr. Okay, and to do that I have to take x, y, z values, okay, which relates with the spherical coordinates. So to find dx by dr, if I differentiate dx x with respect to r, I will get sin theta cos phi. Similarly, dy by dr will result with respect to r, if I differentiate, this will be 1. So sin theta sin phi, dz by dr will get cos theta. So substitute everything here, I will get the unit vector in terms of the Cartesian unit vectors. Okay, the unit vector AR cap. Now let us see the second unit vector, that is a theta. For that, the differential length has to be differentiated with respect to r d theta, not r d theta. It is the differential element. So for that, if I differentiated dx, the x with respect to r d theta, r and r get cancelled. I have to differentiate with respect to theta only. So what is the differentiation of sine theta? It is cos theta. This cos phi remains the same. Uh, in case of y, if I differentiate y with respect to r d theta, r, the sine theta will be cos theta and sine phi remains the same. And here if I differentiate with respect to r d theta, this r will get cancelled and differentiation of cos will be minus sine. So substitute all the above in this equation, we will get the unit vector a theta cap. To find a phi unit vector, I have to differentiate the Cartesian differential length with respect to r sine theta d phi. Okay. So if I do that, the r sine theta will get cancelled. Differentiation of cos psi, okay, will result as minus sine phi. And here y component, if I differentiate with respect to r sine theta d phi, I will get the differentiation of sine as cos phi, and here there is no phi term, so the entire result will be 0. Substituting in this above equation, we will get the value of a phi cap. So now clubbing all the equations as a matrix. So if I was given a unit vector in Cartesian coordinates, I can find the unit vector in spherical coordinates. So we have to just write each of the values in the order AR, A theta, A phi across first, second and third row. If I want to find the reverse, that is want to convert given spherical unit vectors to Cartesian unit vectors, I have to take the transpose. It is going to be like this, row converted into columns. Okay. And to find the component of a vector along the spherical coordinates, that is AR, A theta, A phi. If I was given AX, AY and AZ, I have to take this unit vector AR. Okay. For the first row, I have to take the unit vector AR only, and across each column, I have to multiply with the AX vector and get dot product AY vector, similarly AZ. So first case, let us see AR dot AX. So the X component AR dot AX means this completely dot product by AX. So rest of the terms will get 0 because you know the dot product of same vector only, I will get 1. So sine theta cos phi term will come here. Similarly, if I do for the second, my AY component only will be retained, sine theta, sine phi. Similarly, for the third, cos theta term, the term will be retained. If I compare the unit vector and the vectors along each of the direction, the component along each of the direction, both will have the same set of matrix filled here. Okay. Thank you everyone for watching this video. Let us meet in the next session.